Hello everyone, welcome to Business 526. This is week 8. Week 8 is a week that we're going to have our midterm exam. But before that, I'm going to actually walk you through the solutions for all the homeworks. It will give you a good idea of the knowledge that you should know after 7 weeks study of database management, as well as give you the opportunity to know any of those knowledge that you are still not familiar. And hopefully through this homework um, walkthrough session, you will actually get more detail about how we use SQL to realize the database management tasks. So as all our homework are based on sales order example database, and what I put here is typically use that database to start, and we also need to get very familiar with the tables in the database. And it has a few tables. Many of them we have already used in the past. To check the relationship among those tables in sales order example database, you can always refer to the schema at page 724 in the appendix B of the textbook. It gave us the detail of what variables, what columns in each table, as well as what column is the primary key and what are the formula keys, as well as the relationship among them, how to connect those tables together. Okay, now let's start with homework 3 solutions. In excuse me. In homework 3, let's look at the first problem. Which state the employee comes from? Okay, this is directly a direct result from one table. It is in employee table. Let's look at it. What are the columns in the employee table? You may actually be very familiar with the table, but let's just pretend that we have no idea about the employee table and we want to look at it. So the describe employees give us the columns for that table, and actually we're interested in the state, the employee state column. And we want to know where are those employees that comes from. So we just simply run select distinct employee state from the employees. The key point here is by using distinct keyword, we remove any of the duplications. So like Washington, Texas, it appears multiple times in the employee table, but by using the distinct keywords, we only keep these distinct ones. Okay, the second problem is find all the employee with zip code equal to 98105. So again, this is also related to the employee table, and also there's order by as their last name, first name, all in descending order. And let's look at the employee table again. So we found out there's the employee first name, employee last name, and the employee zip code. So the employee zip code, it is actually a character. So even though it's numerical values, looks like numerical value, but the type of this columns is variable characters. So we're going to use where to filter the employee zip code equal to 98105. Okay, let's do that. Then actually there's only one employee in the zip code 98105. So the order by employee last name, DSC is a keyword of descending order. Employee first name and last name both are in descending order. And to look at the effect of the order by, we can actually do another experiment. So this is not the solution for problem number 2, but it's just like to show you what the order by really mean. Okay, in this one, we're going to look at the employee's first name, employee last name for all the employees, regardless of their employee zip code. And we're going to order by them with last name, the first field, the first order by last name, then by first name. Both are in descending order. Let's look at it, what the result is going to be. Okay, so as we have asked the program to do, it is actually ordered by the last name first. So if there are employees have the same last name, they're going to show up together. But when they have the same last name, we're going to order the order by the employee with the same last name by their first name in descending order as well. So the first employee last number is started with V. The second started with V as well. The third one is T. So you can see the last name is in descending order. And for the same last name, then if there are multiple names with the same last name, then we're going to order those by their first name in descending order as well. So for the first two employees we show here, they have the same last name, but their first name are different. And David is ahead of Carol because we're ordering them by their first name in descending order. And the same lady for Peterson. There are two employees with the same last name, and their first name actually was used in descending order to order those two. So this is basically how the order by when we are using multiple columns in the order by, what that really mean. Okay. Now let's go to the homework 4. In homework 4, we have a few problems. The first one is again sales order database. The first one is, what if we adjust each product price by reducing it 5%? In this one, we're going to use the product table. Let's look at it. What is inside the product table? Your product number, promo name, and your retail price. So in this one, we want to show a discounted price is 5% less than the retail price. Okay, so to do that, we are going to use the products table, and we can actually apply some simple operation with the columns. In this one, we just fan of the product or the retail price and 0.95. We can use as the keywords to define that as a new column name. Okay, by running that, we have the product number, product name, retail price, and the discount price. That is actually, I gave that column a name called discount price. And this is 95% of the retail price. That kind of reducing it 5%. Okay, second problem, show me a list of orders made by each customer in descending order, date order. So in this one, there will be kind of different ways to make it happen. This is actually only involve one table. It's called the order table. In the order table, there are odd number, order date, customer ID, etc. So in this particular one, we want to know for each customer all their orders and all those orders in the order date, descending order date. So we want to return a table that we have the first customer and all the orders belong to the first customer ordered in descending order date. So the first customer, second customer, etc. So because we want a particular order like that, so we're going to need two columns to order by. The first one is customer ID in ascending order. The second one is the order date in descending order. Okay, let's see what will happen. Okay, so as we expected, after we select the customer ID, order date, and order number, it actually showed us the customer ID 1001 show up first, and we list all the orders for customer 1001, and their order date is in descending date ordered. So that's basically for customers 1001. He or she made a lot of orders, and then once the orders for 1001 are finished, we actually come to the next customer 1002, and that's all the orders made by 1002 and in descending order, etc., etc. So this is basically using two columns in the order by to create a table that that meet our requirement. The third one is compile a complete list of vendor name, address in vendor name order. So this actually is only related to one table. We have the vendor table, but what we want here is a list of vendor name and address. So what we need to do is actually to create a new column by concatenate variables columns together and with some separators. We usually use the comma and the space to separate those different fields and glue them together. Okay, let's look at it, what happens. Okay, so we do have the vendor name as separated. It is one of the original column, but the full address is something that I created with four different columns. In those columns, I actually separate them by comma and space to make it prettier looks like. Then we're going to order them order by the vendor name. So that is actually fairly easy, and the only two thing is the concatenation functions in MySQL Workbench are different from what is illustrated in the textbook. So whenever you want to combine multiple columns together, use the concatenation function. Okay, the next question is give me the name of all vendors based in Ballard, Ballyville, and Redmond. Okay, so this is also related to only one table, the vendor table. Let's look at it. What is in the vendor table? We have the vendor ID, vendor name, etc. And then there is a vendor city. Vendor city is a character, and we want to filter out the vendor city in these three cities. So we're going to do the very typical way of select vendor name from vendors table, where vendor city is in Baylord, Ballyville, and Redmond. So sorry, I made a typo here. It should be lowercase. So let's see what will happen. Okay, we found out that there are actually three vendors in these three cities, in one of the three cities, Ballard, Ballyville, and Redmond. And you can see that the in is a special operator, so it's more like a membership. The vendor city is one of the members in this collection of cities. So when we are using in, we need to put the members in this parenthesis. Okay, let's look at the next one. Show me an alphabetic list of product with a retail price of $125 or more. So this is related to a filter as well. So it is related to the products table. Let's look at it. What are the columns in the products table? In the products table, we have the product name, product number, etc. There's a retail price. And what we want to do is we want to filter out the product name based on their price. The price is larger than or equal to $125. And the retail price is actually a number, it's a decimal number. So we can use this numerical value directly. So that's the retail price and larger or equal to 195. We select the product name, retail price from the product table, and we want to order by the product name. Okay, that's the result. The result are actually ordered by the product name in an alphabetic order. That's what really mean by alphabetic order there. Okay, the next problem is what vendor do we work with that do not have a website? And this is related to the vendor table. Let's look at it, the vendor table. So the vendor table, there's vendor ID, vendor name, etc., etc. And the column that we're interested in is the vendor web page. And some of the vendor web page actually there is null. It's kind of null value, and we want to filter out those vendors that they do not have a web page. So to do that, there is a isNull operation. So any of the vendor web page which is null is going to be included in the result. Let's see what are those vendors. Okay, we found out 4 vendors that they do not have a web page. To check whether it is true or not, let's look at all the information in the vendors table. Okay, if you use select star from vendors, it's going to return everything from the vendors table, and there's a vendors web page, and we do find out there are a few, actually 4 vendors, they do not have a web page, and their value is null. It is exactly the 4 vendors that we returned from this query, which is a confirmation that yes, it is right. Okay, the next problem is use the sales order database to find out the unique customer ID in descending order who ordered before 2012 December 31st and their product was shipped at 2013 January 1st. It is related to the orders table, and we need the customer ID, and also there's a filter. It's a complicated filter because it is kind of combined by 2 conditions. The order date is less than 2012 December 31st, and ship date is exactly equal to 2013 January 1st. In this particular one, we want to order by the customer ID in a descending order. So let's see what will happen. There's actually only 2 customers who made their order before 2012 December 31st, and their order was shipped on 2013 January 1st. So this is a more complicated condition. 2 conditions connect with AND operator. So there's AND OR operators, 2 different kind of ways in the logic, as we described in the textbook and in the presentation. Okay, now let's come to the homework number 5. The first problem is list customers and the date they place an order, sorted in order date sequence. This is actually where we're going to use multiple tables to return the result. In this particular one, we do need the customer table as well as the orders name, the orders table. Let's look at it. What is in the customer table? We have the customer ID, first name, last name. That's something we need. The orders table, what we have is order date, and that is what order number, order date, and customer ID. So based on these 2 tables, we can have the result that we want. So how to do that? In this one, because we're actually using 2 different tables, so we have to put in a identifier for each table before the column name. Otherwise, the program actually will confuse which table to return the column names. So we're going to use the customer table in the order table. We're going to kind of like join. It's using an inner join of the customer and orders, and join on the customer's customer ID and orders customer ID. So the customer ID is a linkage to those 2 tables. And what we want to return then? What we want to return is the first name, the customer's first name, the customer last name, the order date, and order number. So be careful that those columns are actually from different tables. We have to put in the table name in front of the column name and separated by a dot. And also we want to order them by customer's last name, first name, and order date. As you can see, our first customer, Sam's and Loris, and who have made quite a few orders. So the orders is in ascending order, and after the first customer, we have the second customer, etc., etc. So those are actually return the information that we need for this problem. Okay, so the next problem is display all orders, the products in each order, and the amount owned for each product in order number sequence. So in this particular one, we're going to need two tables, the order details table and the products table. In the order details table, we have the order number, product number, quoted price, and quantity ordered. So from that, we can get the total number of dollar amount for each product number. But also we need the product's name information, which is not part of the order detail table, but the products table. So we need to link those two tables together and by the product number. The product number exists in both tables and is the link to combine those two tables. So in this one, in this example, we use a alias, the AS. So the order detail is actually will be represented by OD, and the products will be actually represented by P. By using the shortcut, actually we can save some of the space and make it easier to write your SQL scripts. So in this one, we actually inner join those two tables on the product number, which means on the OD's product number equal to P's product number. And then we have the order number and product number are from the OD database, which is the order detail database, and the product name from the P database, the product database. And we also create a new column, what I call a amount, which is the product of the coded price as well as quantity ordered. So those two, the product of those two give us the amount owed for each product. Okay, that's right. It gave us the order number, the product number, the product name, and the amount owed for that particular product. So, okay, that's it. Now let's go to the next problem. Show me the vendors and the products they supply to us for products that cost less than $100. So this one, we need to find out the vendors and the product numbers that are actually less than $100. So we have two tables to actually make it happen. So from the vendors table, we know what is the vendor ID, what is the vendor name. So we need the vendor name. For the product vendors table, it actually has a product number, vendor ID, and a sales price, wholesale price. Vendor ID is something we need to connect those two tables, and we do need the wholesale price to give us a filter. So in this particular one, what we're going to have is we're going to use the vendors table, inner join with the products vendor table, and join on the condition is the vendor ID is equal to products and vendor ID. And we need to put a filter. The filter is product vendors wholesale price. That is wholesale price in the product vendors table is less than $100. So by doing that, we only select a subset. That's the vendors and products that actually cost less than $100. Okay, those are the list of the vendors and products that actually are less than $100 in cost. Okay, now let's come to homework number 6. Homework number 6. Display customers who have no sales representative or employees in the same zip code. So this problem need kind of like an outer join to join two tables. So first of all, we need the customer table and the employee table. And in both tables, there's a column called the zip code. For the customer table, it has a column called the customer zip code. And in the employee table, there's a column called the employee zip code. Those are the linkage to connect those two tables. So what we're going to do is we're going to join those two tables. But we know there are customers actually whose zip code, within whose zip code there's no employee at all. So to keep all the customers, we have to use the left outer join with employees. So that's why we have the left outer join. The left outer join will keep the record that there's a match, as well as the record there's no match in the on condition, to keep anything that in the customer table which is before the join statement will be kept in the final result. So in this particular one, we are going to join the customer with employees table with the left outer join, which means for any of those unmatched customer rows will show up in the final result. So to join those tables, we're going to select the customer zip code is equal to employee zip code. So for one zip code, we're going to have we're going to merge them together. In this particular one, what we're interested in is for any of the customers, there's no employee in their zip code, which means the employee zip code will be null. So we're going to filter out any of those employee zip code is null from the final result. Let's see what will happen. You can see that there are some customers, their employee zip code is actually null, which means there's no match from that zip code, which means there's no employee in that same zip code as the customer. Okay, that's an example using left outer join. The next one is list all products and dates for any orders. In this particular one, you may kind of recall we have solved this problem, similar problem in the past. And what is anything new here? Okay, the new thing here is list all products and the dates for any orders. So it's basically there are some products that never has been ordered yet. For any of the products that have never been ordered yet, their order date should be null. So to make that happen, we need to join multiple tables: the product table, and order detail table. So in this particular one, the order detail in the order table, this one actually we can use either a inner join or right order join. It actually doesn't matter much, because for any of the order there will be order detail. For any of the order detail there will be order number corresponding to them. But the more important thing is, after you join those two tables, we need to join with the product table. Now we're using the right order join, which means the product table, in the product table, if there are nothing matched to the on condition, it will still be kept. Those columns from the product table will still be kept in the final result. That is actually for any of the product. If there's no order number associated with that, those products will be show up in the final table as well. And also at the end, we order the result by order date and product number. For any of the products that has never been ordered in the past, the order date will be null. But we're using the right join, so the product that has never been ordered will be show up in the final result. We do see for those two products, the order data is null, which means they haven't been ordered yet by any customer in the past. So from these two order join examples, we can see that order join are usually to fan out some of the record that actually, or to include some of the record that actually will involve some of the null values. Okay, that's the last homework 7. And as you can see from homework 3, 4, 5, and 6, it's getting more and more complex. We're using not only one table, but multiple tables. And we're actually joining multiple tables, left join, right join, inner join. So those are all covered in the past. So homework number 7 is focused on the subqueries. So let's look at the first one. List the customer who ordered a helmet together with the vendor who provided the helmet. Okay, I'm sorry. Actually, this first problem is actually related to units. Okay, in terms of unit, it is trying to combine two pieces of data together. And in this one, we actually is going to first return customers who ordered the helmet, and then fan out the vendors who provide helmet, and then we combine those two pieces of information together, use unit. And actually, this is exactly what the same piece of code that we showed in one of the presentation a few weeks back. This is how you can get the customers who actually order a helmet. And this is basically very similar to that. It's fan out the vendors who actually order a helmet. So there's actually only one column from the result. The first piece will give us the full name for the customers, one column. The second piece give us the vendor name, one column. And those we can union those two pieces together. It actually will give us the all the result. Okay, including the customer name as well as the vendor's name. So union is a relatively easy topic, but we have to keep in mind we can only union similar results, which means they have the same number of columns, and the corresponding columns has to be comparable with each other. Okay, let's look at the next problem. Display products and the latest dates each product was ordered. Okay, so this is related to the subquery, and you can actually use different ways to return the final result. But this is just one way that I'm going to show you how to use subquery to make it happen. So in this one, we actually is going to use the product table, the order table, and the order detail table. So let's look at the main structure. The main structure is we're going to select the product number and product name from the product table. So this is the key elements. So the product number and the product name can be returned directly from the product table, but the order date is actually returned by this subquery. Okay, and it is after we have that, it's actually be named as the last order. So in this particular one, what we're doing is we're going to select the maximum, the order date from orders, and we're going to inner join this order table with order detail table. And because in the order table we do not have the let's look at the orders table. So in the orders table, we do not have the product number, And in the order detail table, we have the product number. So that's why we have the product number here. We want to use that product number to filter out the order detail. From the order detail, we link to the order table to return the order dates. So this is how the subquery is actually used. Okay, so this order details product number and the product number, they are set to be the same. This actually the product number is from the product table, and for each product number we're going to find out all the orders related to that, and then choose the maximum order date, which is the latest order date. It's the last order date. Okay, so let's try it. We find out the product number, product name, and last order. So in this particular one, as before, we do have two products that the last order date is null, which means there's no customer has ordered them yet. So that's actually two products as we've seen before. Yeah. Now let's come to the last question. No, not the last question. The second last question here is list customers who order bikes. So in this particular one, we're going to use the category table. In the category table, we found there's a category called bikes. Let's look at the category table. So in category table, there's only two columns, category ID and category description, and there's actually a category called bikes. So in this one, what we're going to do is we're going to find out the customers who order bikes from the customer table. So we're going to select the customer's ID, first name and last name from the customer table. And the filter is actually where we build this subquery. So where customer ID is in this subquery. In this subquery, it's actually going to return the customers who actually ordered bike in the past. Okay, how that happens? Okay, we'll actually select the orders customer ID from orders table, which is the inner join with order detail. In the order detail, we on the order numbers, and then inner join with product, because product is going to have the product number to link the order detail to the product table. In the product table, it's inner join with category table as well. Then there will be a column which is the indication of category on the category ID. Then we apply filter. Basically, the filter is the category description is equal to bike. So by this kind of like subquery, we find out all the customers who actually order a bike from historical orders. So this is another way to use subquery in the filter to actually get the result we want. Okay, finally, it's the last problem. The last problem is what products have never been ordered. So we're actually come to this same problem again, but this time what we're going to use is to use a subquery. Okay, we're going to select products table's product name from the product table. The filter is product number is not in that collection. In this collection, what we have, like on membership, in this collection, what we have is select distinct order details product number from order details. From the order details table, we know all the products that has been ordered. So, but we use a distinct to only return a unique representation of the product that has been sold. And not in is actually we're trying to find out any of the product that is actually haven't been sold yet. So this is exactly what we can do to return the product that haven't been sold yet. Again, it is those two products as we've seen before. So that's it. That's all the homework problem solutions. And hopefully after this walkthrough session, you have a better understanding of the how the knowledges that connect together, and hopefully it will help you to study for the midterm exam scheduled for next week. Okay, thank you.